All right, so we are going over even, odd, and increasing and decreasing for functions today. And I did order some labels, so eventually I'll be able to print pictures that you can just slap in your notes. And the pictures that you see are more just like as a visual. If they help you, write them down. If they don't, ignore them. Can I scroll a little bit? Can I go past even? All right. All right, so just try to sketch those as best as you can. All right, ready to talk a little bit? So do we recognize anything right away? What do we recognize? No, A is not a function, but what am I trying to figure out? If it's even or odd. So typically, it can still be even or odd, regardless of whether or not it's a function. All right, because like a circle could be reflection, right? So this one right here for B, this is even, okay? Because remember, even is a reflection over your y-axis, all right? C is going to be odd, come on, because it's rotational symmetry, all right? So quadrant 1 to quadrant 3. And then A is neither. Oh, this thing's going to be in for it today. Okie dokie. So far, so good. So the pictures aren't too bad. Eventually, we're going to start working into solving it algebraically. So I wrote out a step-by-step guide. If you've had me in the past, we've done identifying even, odd, and neither before. So my big thing with this is always start by checking even, because you do need part of it to check for odd. So what's the point in having to double the work if you know you're already going to need to do it? All right. We want to do one with me and one with your neighbors. What are we thinking? Are we thinking it's first period and we're exhausted? Which one do you guys want me to do? A, B, or C? B? Alright, so first thing I gotta check is f of negative x. Oh, this thing is just gonna be ridiculous today, I can tell. Please hold. Alright, and I know it's g of x, but we're just gonna check f of negative x. So what you do with this is you're going to plug in negative x cubed minus 1. So what is a negative x cubed? It's still negative, right? So, is that the same thing as the original? Nope, so it's not even. Next thing I'm going to check is negative f of x, so I can check odd. So that is negative times my original function. Distributing that negative through gives me, is this the same as this? Nope. Stupid. So this one's a neither. As bad as we were expecting, not as bad. All right, cool. Let's do this side of the room checks A, and this side of the room checks B, and then, do I have candy? I was trying to see if I had something to bribe y'all with, but I don't. I'll have to go pick up some candy. Yep. Conceptually, it means there's no y-axis symmetry and no origin symmetry. That's literally it. There's other symmetries because you can reflect it over any given line, but even and odd are the main two. I found Starburst. Once you've chatted it over with a neighbor, do I have somebody from each side who wants to come write it up or no? Go for it. Anybody on this side? let you write 2 at a time, but he's done, so your color down at the bottom neck. All right, Chase, come grab it, Starburst. And I did get us mice for my math lab. It'll help, especially when we get to graphing problems. It's harder than it looks writing up there, isn't it? All right, so even, are we in agreement for A? Anybody see a little problem for C? Yeah, you forgot that, homie, right there. That's okay. So this becomes a positive, which now matches this, so this one's odd. And I'm actually glad you made that mistake, because it's been happening quite a bit. You have to actually plug it into every single X that we see. All right, not just necessarily that first one. Right, do we need a minute to write down those fixes? Up next, we've got increasing, decreasing, and constant. So these are the book definitions. And I don't necessarily want you to write those quite yet, because let's be honest, those are a little excessively, technical. Okay? A function f is increasing on the interval I if, for any choice of x1 and x2 in I, x1 is less than x2, then f of x1 is less than f of x2. That's kind of ridiculous, isn't it? So basically, if you have to explain it like you're 5, alright, so explain it like I'm 5, how could you rewrite that to make it easier to understand? Yep. So you've got some x1, and that is less than that same x2. Then when I plug it back in, my y values should be the exact same. All right? Where if x1 is less than x2, then y should be less than the other. Right, when I plug it in? I used some of the same notation, I just made it a heck of a lot less scary. Decreasing. If I wanted to rewrite that, if you notice, the x1, x2 is still the same. The only difference now is that change right there. So for some x1 is less than x2, then the y's, f of x1, should be bigger than f of x2. And if we had to draw it, this one goes kind of like this, and this one goes like this. Alright, should still have a smaller x1, but when I plug it in, that number is going to be bigger than the next number I get. And then constant is literally for any x over an interval, the y values are all the same. Now, you do want to make sure that you choose everything in between, because let's think about a quadratic. If you're just looking at endpoints, I could have some x1 and some x2, they could go up, down, and all over the place and end at the same spot, but that's still not a constant graph. You have to have everything in between connect and have it be straight. Okay? A little easier to understand than the book definitions. So, I have a picture. Oops. So we are going to determine the following, leave a couple spaces, and try to sketch that picture in if you can. Alright, so we just want to go through the list. So, question 1 is, what are my intercepts? And how many do you see? Okay. What about this little section right here? Does that count as x-intercepts? What are we thinking? This little chunk. I would agree with that. What do you guys think? Because if you think about it, there's infinitely many quote-unquote intercepts going through here because they all hit 0, right? So the way typically in math we define intercepts is crossing, okay, going from above or below or left to right. So I would say we've got a y-intercept at 0, 2, and then x-intercept at 2, 0, and 4, 0. And the weird looking plus thing is how I do my ands. I can't do the big fancy ones. They have 7. Domain. Someone over yonder. Give me an idea. What are we thinking for domain? Yeah, -4 to 4. So you want to look left to right, and you're just looking at your x values. So if we're doing interval notation, -4 to +4, because both of those end dots are closed, so they count. And if you're doing set builder, x such that x is between -4 and +4. Someone want to talk about range? Yep. So for range, you're just looking at y values. So I've got -2 to +2, y such that have you noticed on some of the questions on MyMathLab, it won't tell you necessarily what format they want it in. So if you click View an Example and you click to the end, it'll show you how they want you to input it. That helps. Yep. So it's not lazy, I'm efficient. I want to hurry up and get this done. What do you want? Because you're not telling me. All right. So up next, and I'm just going to scroll a little bit and move this thing down so we can see the ending of it. I've got increasing, decreasing, and even and odd intervals. Or constant and then even, odd, or neither. So where do you want to start? What's the easiest one? Constant. So I've got constant happening from here to here. All right, so my constant interval is going to be -4 to -2. And if you had me last year, we always considered the point where it changes from constant to either increasing or decreasing as a turning point, my math lab will consider it a closed interval. Okay, so we always did parentheses last year because that's the calculus way of considering turning points. But my math lab's stupid. All right, so from here, constant, what happens next? If you're looking at my graph, increasing. All right, so this is increasing from -2 to 0. And what you'll notice is when I do this, I read my graph from left to right, so I can kind of figure out, okay, constant, increasing, and then I just go through the whole graph. So what happens after I finish increasing at 0? Decreasing. Now, it doesn't matter that this way of decreasing is different than this one. It's still decreasing there. Okay, so my decreasing interval is going to be from 0 to 3. And then it starts increasing again. Three to 4. The last part is even, odd, or neither. Do you guys see reflectional symmetry? Do we see rotational symmetry? So it's neither. And ta-da, we're done. So, the homework is down here at the bottom of the page, but it's also on the calendar, which is definitely